50,000 years ago, on the verge of extinction, man harnessed fire. Our first technological achievement and our catalyst for survival. The catalyst for our creative spirit, for our ambition to build and construct. But with all creation comes demolition. Now, 50,000 years later, the Boodarie iron site is one of the largest, most complex demolition projects undertaken by any demolition company in the Southern Hemisphere. Located in one of the most remote and desolate parts of northwestern Australia, this site was built to withstand cyclones and earthquakes. Even Mother Nature herself could not tear this man-made colossus down. With structures that tower 100 meters high, comprising of over 25,000 tons of steel, the Liberty Industrial Demolition Team will bring it crashing down with unseen power and precision. Within 12 months, what you see may as well have never existed.
The plant's situated in a town called Port Headland in Western Australia, in the northwest corner, out in the middle of nowhere.
The HBI plant consists of three main structures: a briquette structure, a reactor structure, and a gas plant. Collectively, the project scrap tonnage is approximately 25,000 tons. The briquette structure stands 65 meters high, and the reactor building stands 100 meters high. That's taller than the Statue of Liberty. Within the relatively low-lying structures of the gas plant stands a 100-metre high stack, which is the tallest structure in that area, and the only one in the entire plant that will not be demolished. The Boodarie HBI plant for hot briquetting iron ore was primarily designed to make briquettes out of the iron ore fines. At the time the plant was built, there was a lot of it, a result of the mining process. These briquettes would then be exported overseas. As the mining process slowed, the plant became a relic of a once busy mining time, and now the primary structure which graces the skyline will be demolished. The removal of this plant will enable Liberty Industrial's client to move forward with their multi-billion-dollar expansion project. This demolition is the first step undertaken in this process.
The duration of this project's approximately 12 months, and that's done in basically 3 stages of the reactor, the briquette and the gas plant.
This structure we have to have down by Christmas, which is 4 months away. By Christmas is the cyclone season's coming in, and we'll be getting slapped around with a bit of wind. So that's not a thing you want when you're doing demo.
The plant is situated right in the middle of the largest cyclone belt on planet Earth, an area that experiences some of the most extreme weather conditions, including winds that can top 250 kilometers per hour.
The structure's built to withstand a Category 5 cyclone, so it's basically built not to fall down.
Due to the plant's extreme isolation, it's a massively difficult process to move all the crew and equipment into position, followed by the removal of over 25,000 tons of steel. To put this into perspective, the amount of steel removed could be used to build the Eiffel Tower 3 times. Combined with the demolition itself, it becomes clear that the Liberty Industrial Team must perform with military precision. Further complicating the process, all the structures are very strong and rigid. Weakening them is a very complex undertaking. With a monster-sized project such as this, monster-sized gear is required. Liberty Industrial employs the use of 9 excavators, including 2 of the largest custom-built demolition excavators in Australia. Here is the largest demolition excavator in the Southern Hemisphere, the 230-ton Liebherr 994, with its unique custom-made set of grapple attachments that weigh in at 14 tons. This monster of an excavator elegantly towers above all others on site and required custom modification to realise its true demolition potential.
They only actually make a set of grabs up to 160-ton excavators, so they had to take the grabs off a 160 and beef it right up with heavier plate steel.
The machinery employed in this project is truly like no other. But this arsenal of state-of-the-art demolition gear is only as good as the team who operates it. Liberty Industrial's crew of 30 on-site specialists, the best of the best in the industry.
We've got Simon and Clinton, who are our 2 directors, who work out of our Sydney head office. Then on site we have myself as the site manager. Then we've got our supervisors, Wayne Walker and Ryan Kinney. We've got 2 relief supervisors in Lee Whale and Darren Carstairs. Then we go down to our operators, Michael Morrissey or Minga, Matt Ward-Massey or Ginge.
Minga generally operates our heavy plant like he's in the 220-tonner. There's young Ginger, he'll be in the 120.
And we've got Gary Joyce. Gary's one of our operators come oxy cutters. Don Hayward, Nigel Crawshaw. Nigel's one of our operators and cutters. And then we've got Nigel Howson, who operates our shear. Gerard Scanlon, Peter Lambert, our safety officer, and supervising the gas plant for me is Ryan Kinney. Basically all of us are all-rounders, so whether it's be rigging or operating plant or oxy cutting, we all just take from one place to the other.
The stakes are extraordinarily high. If the demolition doesn't go as planned, half-collapsed, unstable structures could be left standing, not only exponentially increasing costs, but also exposing the crew to highly dangerous conditions. When even the smallest miscalculation could place the entire project and its crew in jeopardy, the Liberty Industrial team must look into the future and assess any potential problems before they arise. Pushing aside the brunt forces of the on-site machinery, this is the most technologically advanced tool in Liberty Industrial's arsenal. Extreme loading software using AEM is a breakthrough development in demolition pre-visualization. This advanced software simulates automatic crack initiation, separation and collision of materials more accurately than any other structural analysis technology to date. This world-class software acts as an oracle for every kind of demolition. Seeing problems and potential demolition hazards before they happen is what the brain of this computer system is designed for. The program can simulate from local failure to global response and everything in between. This allows Liberty Industrial to be one of the few companies in the world that can effectively watch the collapse of a structure before even setting foot on the demolition site and before the first cut is made. This cutting-edge technology is the most advanced software on the planet, and Liberty Industrial is the only company in Australia using it, ensuring they orchestrate the most efficient and safest demolition process possible. The Boodarie HBI closure project is one of the client's top worldwide risks, not just because no other demolition of this size has been attempted in over 15 years, but most significantly, because of the highly volatile DRI that lurks within.
The main contaminant we have on this site is what they call DRI, and it comes from the process of getting the iron down into its purest form.
DRI is an acronym for direct reduced iron. It's a hazard because firstly, it's like all very finely divided pure metals. If it's scattered in the air and ignited, it can be explosive. And secondly, it's hazardous because if you put water on it or steam on it, it reacts forming hydrogen gas, which of course explodes even with a small spark. The major steps we're taking here to make sure we don't get an explosion is to make sure we don't allow it to collect or remain in hard, strong vessels. We're opening them where we can in a very safe manner, and once we've done that, we're going to spread it and then allow it to oxidise. Secondly, it's a real problem because as it's so fine, if it gets in people's eyes, it can give you severe eye damage. As far as dust goes, everybody's got to wear mono goggles when working around it and breathing respirators.
Liberty Industrial will demolish every section of this plant via induced collapse, which first involves strategically weakening the structure with precision cuts.
We work with the engineers and they'll be able to give you pull forces and you come up with a plan. So then you come into your structure. Engineer will write you up a procedure which you'll follow, when to attach your cables, hold them in slack so you don't put tension on the columns as you're cutting. Then we come in, the supervisor generally marks up the columns where they've got to be cut, and you have your crew come through and they start weakening the structure. And eventually we get to apply a bit of pressure on it and it falls over.
But not all structures will be pulled to the ground by excavators. In one remarkable instance, use of controlled, precisely placed explosives will cause the collapse of the structure itself. But why collapse the structures in order to take them apart? The idea of pulling the structures over when they're relatively high is to take the inherent risks out of working at heights. The structures are collapsed to a height where the excavator fleet can then safely demolish them. These methods virtually remove any need for personnel to be working at heights, thereby eliminating one of the biggest risks on a demolition site. With all the elements in place, the Liberty Industrial team focuses its attention on the first structure to be demolished, the Briquette building. Given the complexities of the Briquette structure and the heavy nature of the building, it's taken some time to devise the methodologies and the analysis to ensure sufficient pulling force on the machines to be able to pull the structure over. The weakening cuts have been specifically designed so that it collapses relatively simply, but also ensuring that the structure is sufficiently standing so that it doesn't prematurely collapse without warning, or worse, while the team is still working on it. 8 weeks to design the methodology. 1.5 months to prep the structure. Just 13 seconds to fall. The structure will fall in 2 halves. The top section will be removed first, and then the bottom section will follow. The structure will be weakened by skilled oxycutter personnel. These areas of the structure have been verified by the team's structural engineer, and Liberty Industrial has run demolition analysis on the building and methodology using ASI Technology Extreme Loading software.
Put the tension back on again, nice and slow.
When the structure is fully weakened appropriately, the operators will take the load on the cable and systematically track backwards, applying force to the cables, which will in turn pull the structure over. Weakened sufficiently and pulled so it gains momentum, the structure collapses in a perfectly orchestrated symphony of physics, gravity, and steel.
What we did after the building came over, we got Rob to do an inspection for us to actually see how much it actually decanted out of the holding bins in the structure, and he basically given us the all clear that it's safe to proceed.
The heavy plant will come in now, disassemble all that. That'll be downsized, put onto the moxies, taken down to the scrapyard where Big Nige will look after all that. By shearing it up, a lot of this structure here won't be sheared because of the sheer size of it. So there'll be a lot of oxy cutting coming up for the guys.
With the first phase of demolition a complete success, the Liberty Industrial team moves on to the next stage. The gas plant is a series of pipe racks, reformer structures and columns. It contains lots of ducting, piping, heavy tubes and heavy plant equipment, but relatively low rise compared to the briquette and the reactor structure. The only exception is its 100-metre tall stack, which will remain standing as part of this project. In this case, the pipe rack sections will be weakened and they will be pulled over using large machines. Primarily, the 230-ton excavator will walk through the gas plant and pull it to the ground in a safe and controlled manner. It will pull those structures apart, and together with the smaller fleet of 46 and 36-ton excavators with shear attachments, it will systematically tear it down and process the material. Only one structure remains to be demolished, but it is the biggest, most technologically difficult part of the entire operation and potentially the riskiest. The reactor structure. A building towering over 100 meters high and with the combined steel structure weighing as much as 10,000 cars. And it's all going to come crashing to the ground. Imagine 10,000 cars falling 100 meters to the ground at the same time. The reactor structure is a different beast altogether. Because of its sheer height and mass, cut and pull methods cannot be used. The Liberty Industrial team will split this structure in half and collapse each half away from the other. For this reason, the reactor structure can't be weakened in the usual way. The oxy-cutting team can only do a small amount of pre-weakening on the steel columns. The crew will weaken the reactor building to a point where it's standing, still rigid and structurally sound, but this is as far as they can go. The final cuts will be completed using powerful explosive cutting charges. When initiated, these charges will fire with precision timing and cut through the columns, forcing them out of the structure, allowing each half of the building to rotate on its back columns and collapse. Turning once again to their state-of-the-art simulation software, Liberty Industrial must strike a perfect balance between weakening the structure just enough so that the explosive charges will bring it down, but not enough for it to collapse on the crew prematurely. As if the complexity of the demolition so far wasn't enough, the reactor building offers yet one more massive challenge to the Liberty Industrial team, or rather 16 of them. The structure itself harbours 16 reactor vessels within the building, each weighing in at approximately 300 tons. In the reactors, there are still large amounts of highly volatile DRI. The plan is to split the reactor vessels in half, so that when they come down with the structure, the reactors will open up and aerate. Then, when the reactor building is on the ground, the crew will leave it in place for 24 hours to settle before any person or machine is allowed to come near. This is the most complex phase of the entire demolition and must be orchestrated to perfection. The force of the cutting explosives must be calculated precisely The timing of the explosives must be accurate to within 1/100th of a second. The reactor vessels must fall and each split open for aeration.
Roger that, clear for countdown.
Everything must go to plan and perfectly on cue. In this majestic symphony of calculated demolition, there are no second chances.
3, 2, 1.
The fall has been a complete success, and within just 8 seconds, the equivalent weight of 10,000 cars has been brought crashing down to earth. The two halves of the reactor building peeled away just as the Liberty industrial team had predicted. Accordingly, every single one of the 16 reactor vessels split open as expected, exposing the DRI contained within to the atmosphere and allowing the oxidization process to occur. The cleanup team can move in to begin the dismantling and cleanup process in a safe environment. With the structure collapsed, there is a systematic method of cleaning up and processing all the scrap metal. Once again, the larger machines will pull the structures apart, and the fleet of smaller 46 and 36-ton excavators equipped with shear attachments will go to work, systematically cutting and processing the scrap steel. As part of Liberty Industrial's ongoing commitment to efficient waste management and environmental concerns, all scrap steel is processed in accordance with strict export guidelines. This ensures 100% of the scrap steel can be recycled for future reuse. All concrete is also being retained on-site and pulverized to downsize and remove the reinforcing, enabling the resulting product to be used on the future redevelopment works. Thanks to this effort, 98% of the waste generated by the deconstruction of the Boodarie HBI plant will be recycled, instead of making its way into a landfill. 12 months later, after 100,000 man-hours and no lost time injuries, the HBI Boodarie plant is no more. With demolition complete, the cycle of creation can begin once again. A new project will begin to take shape, bringing bigger and better technological achievements. And with boundless creative spirit and ambition, man will build once more.